first we turn on the gas. We make sure it goes to 55. That's very important. Then we go and turn on the water here and here. That's the water. That's very important for cooling the system. And then we come and turn on the system. Here there is one here. Then we have the auto sampler. Then here we have the lamp, right? The right side one. So you can see that they are starting to move, so I show that they are starting. Then we come to the desktop, we turn on to the instrument. The login is just admin, and we wait. This window come out, so we're gonna go as element selection. This pops up, we say okay. Then we're gonna go to select element. We're gonna choose copper, and then okay. Next, we are going to, we don't need to do the calibration curve, we just skip it because we're gonna do it ourselves. This is where we wanted to the system do the calibration, but we want to do it ourselves. Now we just do it just does the system check, make sure that all of these are gonna like check correctly. GFA, which is a graphite furnace, like signal to noise check, ROM check, and then the D2, which is the background. Basically that's the wavelength search, is it doing correctly the wavelength, finding the wavelengths, and all of them are different part of the system, make sure they are doing correctly. You can see they are getting green, it means they are working for now. Let's see if all of them are working correctly. It takes time. Okay guys, the OK is now on, so we can hit the OK. It means there is no failure. Then we're gonna wait. It's sending the program to the furnace and checking the furnace, the parameters. It's just the usual check of the system. Meanwhile, I'm gonna show you the auto sampler. Here we have the auto sampler, and you can see that this is a starting number 1. So it's gonna when you come, each person have 5 samples. So you're gonna put your samples. The number 1 that would be the blank one. There basically this is R1 and R2. You can also put, instead of the blank number 1, position 1, you can put in R1, but it doesn't matter. So we decide to put our position 1 as a blank, so that's gonna first do blank from the position 1, which is the 0.16 molar of HNO3. That's gonna be the 0.16 molar HNO3. That's gonna be our blank. Start putting from number 2. You're gonna pour your samples. You know, it takes only a small amount. Put it here. You can use plastic pipette. Put it here, and then 1 sample here. Then you're gonna put another sample, 5 samples. The next person is gonna come and start from the 7 number 7, because the first was the blank, then the 5 samples, so it's gonna be 7, and as go on we're gonna start filling up. Depends who is finishing first, and it's totally fine. You know, we can run another one in the next session. You know, so some of you will gonna do on Tuesday, some of you is gonna be on Thursday. And now the system is already good, so we're gonna lamp on. So it's gonna be a next step. The lamp is getting, so if you might hear the click, it means the lamp is on. We do the line search. It takes time. if you look at the top one, we basically, this is 324.8, this nanometer, which is the wavelength for copper. Because we chose copper, that's the wavelength that is gonna go, always go to find any copper in the solution. So now it should find make sure that it can find the 324.8 nanometer. Now you're gonna see that it's finding. So you can see that this is basically almost at 324.8, is a little bit further. You can see that here is about okay, the line search and beam balance is, then we say close, and then we go to the next. So here we have the how it's gonna do the different changes, temperature changes, at which temperature, and how many second is taking for each of the temperatures, and the heat mode. Here basically shows the sensitivity, which of them is more sensitive, and the gas type will be our argon. And here, can you go to a little bit more? Okay, and here is gonna be the flow rate. So the flow rate of the gas is gonna be 0.1 for the first three temperatures, and 1, and then it's gonna be no flow rate, and it's gonna be 1. This is just the system is already set up for that, so we don't really do anything here. We just say basically that's stages are 3 already for our system is already adjusted. And then we're gonna do high density graphite tube. That's the one, the tube that we are already using. That's this one. And then here you can see here that that's the page that is coming. We start from the blank, the first one. So that would be blank for the first one. BLK. Then we're gonna go to the position 1. It's gonna take 10 microliter. We don't need diluent R1 because we're already using the 10. We don't do any dilution, and total volume is gonna be 10 microliter. This is a standard deviation. This is a date and time that is gonna come up after the system is analyzed. All of them is gonna come up. The absorbance is gonna come up. The background, which is gonna be very small, as basically it's gonna be, I'm gonna show you, we need to subtract from background. And then we're gonna do the unknown, the second position. You're gonna do ID, so it's gonna be your, for example, as we did, for example, VG. And then what's gonna be, for example, your initials, and for example, 5 ppb. Your second one, I just give an example here. The second one, can you go back? PP, another P here. And then the second one will be VG, unknown, VG, and would be, for example, 10 ppb. And so on. You're gonna do 5 samples. The position is gonna be position 1 here, 2 here. We're gonna do 2, position 3. That would be for the, and so on. So you're gonna do, if you have 5 samples, you're gonna go up to the unknown 6, and you're gonna be on to position 6 here. Then the volume is never changing, 10 always. This is always 0. This is gonna be always 10 for us. And the system is gonna give us all of the stuff, background, absorbance, and so on. Here, as you see, you can see based on the temperature, show us the increase, what happens to the system, the 4 steps that I talked about, ashing, drying, and cleaning, the 4. And then here is the background, and here you're gonna see the absorbance that shows up of the copper each time. Okay, and the absorbance also shows up here. Then after everyone is done, so you're gonna put back to back. After everyone is done for that day, at the end of the class or the lab, I'm gonna hit a start here, and we're gonna let it run. It should be take 2-3 hours, so we don't wait for it.